Take a look around you. I mean, really look. The air you're breathing, the phone in your hand, you, me, it's all connected. It's all running on a hidden set of rules. Today, we're going to start decoding those rules. We are diving into chemistry, the science of, well, literally everything. Seriously, have you ever just stopped and wondered, what is all this stuff actually made of? You know, the chair you're sitting on feels solid, the light from this screen is light, and your own thoughts feel like, well, thoughts. They seem totally different, right? But what if I told you it's all built from the same tiny set of ingredients, just snapped together in different ways? You guessed it. The answer is chemistry. And it's so much more than just a class you have to take. Think of it as the instruction manual for the entire universe. It explains why things are the way they are. Okay, so what is chemistry in a nutshell? It's really all about asking three simple questions. First, composition. What's it made of? Second, structure. How are all those little bits and pieces put together? And third, properties. What does it do and how does it act around other stuff? If you can answer those three questions, you can understand anything from why ice floats to how a battery works. But let's be real, this isn't just theory for a textbook. Chemistry is happening all around you and inside you every single second. From the food you eat to the phone you're probably holding, its fingerprints are everywhere. Let's talk about why it really matters. Just think about it for a second. Creating a new life-saving medicine? That's chemistry. Designing the screen you're looking at? Chemistry. Even figuring out how to clean up our planet? Yep, that's chemistry too. It's the foundation for so many careers and innovations that shape our daily lives. So, where does all this amazing science happen? Well, every explorer needs a workshop, and for a chemist, that place is the laboratory. And I want you to stop thinking of it as just a classroom with a bunch of weird glass tubes. Instead, picture it as a place where you can actually see the rules of the universe in action. And it truly is a place of adventure. I mean, world-changing discoveries were made in labs just like the one at your school. But with any great adventure, you've got to know the rules of the road first. Safety is what makes the discovery possible. So let's call this the Explorer's Code. This isn't just a list of boring rules. It's all about respect. Respect for the powerful chemicals you're using, respect for your own safety, and respect for the science. Being prepared, staying alert, and handling things with care, that's what lets you do the cool stuff safely. When you're in the lab, everything basically falls into two buckets. You've got your ingredients and you've got your tools. The ingredients are your chemicals. This is the stuff that actually gets used up and changed in an experiment. Your tools, that's your apparatus. This is all the reusable gear you use to make the magic happen. Let's do a super quick tour of the chemist's toolkit. First up, the conical flask. See how the sides are sloped? That's a genius, simple design to let you swirl and mix things together without them splashing all over the place. Next, we've got the measuring cylinder. Chemistry is a science of precision. You can't just guess. This tool is your best friend for measuring out the exact amount of liquid you need to get your reaction just right. Ah, and here it is, the iconic Bunsen burner. This is the workhorse of the lab, giving you a nice, controllable flame to provide the energy needed to kickstart all sorts of chemical reactions. And finally, the humble test tube rack. It might not look fancy, but this little guy is absolutely essential for keeping all your different experiments organized, upright, and safe. Every tool has its purpose, and together they let us speak the language of matter. Okay, so we've seen the workshop. Now it's time to learn the language they speak there. Because in chemistry, everything, and I mean everything, starts with understanding the absolute most basic building blocks of our world. The first and most important word in this new language is matter. It sounds really scientific, but the idea is super simple. If it takes up space and it has some weight, it's matter. The desk is matter, water is matter, even the air that you can't see is matter. It's basically just stuff. So if matter is the story of the universe, then elements are the alphabet. An element, like pure gold, is a substance that you just can't break down into anything simpler using chemistry. It's as basic as it gets. These are the fundamental ingredients for everything. And just like the letters in our alphabet, each element gets its own 1 or 2 letter symbol. H for hydrogen, C for carbon, and so on. It's a universal shorthand, a secret code that scientists all over the world can understand. But you've probably noticed some odd ones, right? Like, why is sodium Na? And why is gold Au? It seems like it doesn't make any sense, but there's actually a really cool historical reason for it. It's because many of these symbols don't come from their modern English names, but from their ancient Latin names. So Na for sodium comes from the Latin word natrium. Au for gold comes from aurum. It's a little piece of history hidden right there in the periodic table. Pretty cool, right? So, if elements are the letters, what happens when you start combining them to make words? Well, that's when you get compounds. And this is where chemistry gets really interesting, because when elements combine, they make something completely new. Check this out. You take 2 parts hydrogen and 1 part oxygen, 2 gases, and you get liquid water, H2O, the stuff we need to live. Or take sodium, a soft metal that explodes in water, and chlorine, a toxic gas, and you combine them to get table salt, NaCl. That's the magic of chemistry. The words have totally different properties than the letters that make them up. So we've covered the what, the why, and the how of chemistry. We've toured the lab, and we've learned the basic language of elements and compounds. But honestly, we've just opened the first page of a massive instruction manual. Your adventure is just getting started. The only question left is, what will you discover?